Hey everyone, let's quickly derive the formula for this transformation, and then we'll get into just some quick little projection matrices. So to derive the matrix cosine theta, negative sine theta, cosine theta, note that we started at a point x1, and we want to get to this new point x1 star, which is going to be r, whatever radius we were at, however far we are from the origin, cosine of, now our original angle, we'll call it phi, is having theta added to it. And analogously, x2 is being transported from our sine theta to our sine of theta, our sine of phi plus theta, right? This is just basic polar, if you remember that from Calc 1 or 2. Okay, right? X equals our sine of theta, x2 equals our cosine theta, right? So anyway, when we do this out, this is r times the quantity cosine of phi, cosine of theta, minus r sine of phi, sine of theta. And similarly, here we get r, what will this be, sine phi cosine theta minus r, plus r cosine of phi sine theta. Okay? And now what is this? Well, remember that our cosine of phi is x1, our sine of phi is y1, so this is the same as x1 cosine of theta minus x2 sine of theta. And this right here, our sine of phi, remember that that's x2 cosine of theta plus, remember our cosine of phi is x1, so that's going to be x1 sine of theta. So if we just kind of swap these around, we're going to get x1 sine of theta plus x2 cosine of theta. And sure enough, these right here perfectly correspond to our transformation. Okay, so that's how we get that. Moving on, let's project an image onto a viewing plane. Consider a three-dimensional situation where here are our axes. Suppose we've got the z-axis right here, x-axis right here, y-axis right there, right? We normally call these x3, x1, x2, but I'm just going to call them x, y, and z, just so that it's clear what we're talking about. Suppose that we're starting from some value. Maybe I'll use a different color here. Call this value d. Maybe I'll use, right there, d. Okay. And from here, what we're doing is we are projecting onto this plane right here. Okay. So if there's some sort of a rectangle, maybe, I don't know, here, for example, then what we're going to do is we're going to project from D, from that rectangle, onto the plane. Onto the plane. Let's say maybe there. And then it goes to like right there. Well, maybe that's not the best, right? Something like there. Roughly, right? Okay. All right, it goes from there onto like there or so. And then maybe from there onto there. It's roughly right. Okay. So this should give us another rectangle. Let's maybe move this guy a little bit like that. Okay, right. So there's our projection, all right? There we go. Okay, so then the question is, maybe we need to, let me maybe move this a little bit. Sorry, let's check some technical issues here. Wait, no, I think we're okay. Let's see. Let's try this guy one more time, actually. Sorry, that didn't work out quite the way we wanted to. Drawing this one through here. Nope, not what we're going for. We're going for here. Boy, going really far, aren't we? Okay, well, I guess that's where we are. Yep. Something like that, okay? And then similarly, this guy is going to go all the way out there. Okay, that's pretty good. So anyway, what we should get in theory, if I could draw maybe a little bit better, is a rectangle, right? This is what we're projecting to. Okay, and so the question is, what map is this? Well, if we take some generic coordinate, like this guy, for example, that coordinate is x, y, z. Now, really, we need to use homogeneous coordinates, so really it's going to be x, y, z, 1. Okay? Maybe I won't draw that error, but you see where I'm talking about, okay? So we are projecting this coordinate onto this new coordinate, and this is x star, y star, 0, 1. Right? 0 because that's the plane z equals 0. 1 because we're staying in the homogeneous class. So the question is, how do we get that matrix? How can we figure out a projection matrix for that? Well, using some similar triangles, you can notice that, proportionally speaking, this triangle needs to be the same as that triangle. And so when you do it out, you wind up getting x star, I think about, yeah, it winds up being x star over d equals x over d minus z, which gives x star equals dx over d minus z, or if you want to drop the d somewhat, divide the top and the bottom by d, you get this. Okay? Similarly, you get that y star over d equals y over d minus z. And that, of course, gives y star equals dy over d minus z, or y over 1 minus z times d. Remember, there is no z star equals 0, right? All right, so what that gives is this projection matrix. So what they do in the book, this is clever, is they scale by a factor of 1 minus z over d. So this matrix works out. Just so we avoid writing z in our matrix. So we wind up having this, and then we write, I think it says negative 1 over d right here. Whoop, negative 1 over d. And then this is a 1. If you multiply this by x, y, z, 1, you wind up getting exactly what you're hoping for, which is x, y, 0, and then this is 1 minus z over d. Okay? So anyway, why is this relevant? Well, if we have a triangle, for example, and we want to project it from the point 0, 0, 10, and you could just say, well, let d equal 10. And so our projection matrix is the following. It's going to be p equals 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, negative 1 over d, 0, 0, 0, 1. Or sorry, and I guess that's actually negative 1 over 10 is what that is. That. And so you can just find P of each of these points, right? 4.2, 1.2, 4, and then we do need to stick in that 1, right? Because we are using homogeneous coordinates, right? And we know what it should give us, right? It should give us 4.2, 1.2, 0, and then 1 minus whatever z over d is, right? Well, in this case, z is equal to 4, so we're going to get 4 over 10, right? Which we can reduce to, I guess that's 0.6. Okay. Now, if you want to make this, if you want to multiply to get a coordinate of 1 in this case, you can, but I would just leave it like this, okay? Okay, and you can just do the others, right? P of 6, 4, 2, 1 equals, etc. And again, this will be 6, 4, and this will be 0, and then this will be 1 minus 2 over 10, so that's going to be 0.8. Okay? Make that a comma, comma, and then what do we have? 226. Well, that's going to give us 2, 2, 0, and then it'll be 1 minus 6 over 10, which is that. Okay? So that's what you get.